Welcome to the second video clip on bearings. We are still looking at solving general triangles. On the screen we have three questions. The three examples we're going to treat to apply what we learned in the first video clip on bearings. Question 1 and question 3 are questions that would lead us to right angle triangles. And in the next video clip, that's video clip 3, we will see examples that will give us triangles that are not right angle triangle. And in that case, we'll be applying our sine rule or cosine rule in solving. So let's start with example 1. Example 1 states, a male delivery van, starts from a location O and travels in the direction 030 degrees for 28 kilometers. You may already want to represent that. 030 is simply saying we should draw 30 degrees from the north direction. That's the first method we studied in the first video clip. That is 30 degrees that way. So we just take 30 degrees and then we do that. And the question goes further to say that after 28 kilometers, the van then changes direction and travels towards the west. On arriving at this point, decides to travel towards the west. Of course, my west should be that way, until it is exactly north of its starting point. Where is the starting point? The starting point is point O there, and the north of it means up that way, which means this is the stopping point. We'll take it again. A mail delivery van starts from a location O and travels in the direction 030 degrees, that is 30 degrees. Starting from the north direction, we go clockwise as we saw in that video clip, 30 degrees, and then we travel that direction, 28 kilometers. The van then changes direction and travels towards the west. Remember, this is our north, this is the south, that's the east, and this is our west. So the van then traveled towards the west and stopped the moment it is exactly north of its starting point. Now, if you look at that, that means this will be 90 degrees. So we have a right angle triangle. Let's draw this out neatly. That's the first part of it, 030 from O, 28 kilometers, and then from there we change direction. That's the next one, traveling to the west. On arriving at this point, travel to the west, as the white line indicating that, and then stop exactly when it is north of its starting point. So we have a right angle triangle. The question now is saying we should calculate its distance from the starting point. This is where the van is now. So we have to calculate the distance from O to that point. Now looking at this triangle, we can see that at the beginning we have up to two sides known. We would have just applied Pythagoras Theorem. But in this case, no. While we were studying solving right angle triangle, we said that for right angle triangles we can either use Pythagoras Theorem or the SOH CAH TOA, that is Trigonometric Ratios, sine, cosine, and tangent. Here, Pythagoras Theorem cannot work because we know only one side. But looking at the given angle here, 30 degrees, we'll agree that 28 is the hypotenuse, and then this other side will be the adjacent, and y is the opposite. So I can easily do what? I can quickly say, I would have just gone straight to look at what find the adjacent, because that's the side we are looking for. I would have applied cos theta there. I would have said that cos of the angle 30 is equal to what? Adjacent all over hypotenuse. And since we are looking for the adjacent side, we now say if we cross multiply there, it means that what? The hypotenuse is 28. That will be 28 times cos 30 will give me the adjacent. And cos 30, sorry, that should be cos 30. Cos 30 is 0.866. However, the other method we see being applied here is a very long route. We are solving for the opposite side, which is y. On getting your y, we can go ahead and use Pythagoras theorem to solve for this other side. I think there must have been some mix-up there. I'm solving for this. We would have gone ahead and say, oh, 28 square is equal to y square plus the adjacent. Let's call that side x square. I would have applied that rule that way. Or would have just continued from here and said that 28 times cos 30, which is 0.866, is equal to the adjacent side we are looking for. Which any one of them will give us the answer. If we multiply this out, this will give us 28 times 0.866. Let me quickly compute that. 28 times 0.866. That will give us 24.25. 24.25 kilometers. So that's its distance from the starting point. Now, sorry, this solution we have here was calculating for this other side, right? But the question demands that we should look for the distance from its present position from its starting point, which should be 24.25. Sorry about that mix-up. So that's it for question 1. Let's look at question 2. Question 2 states that the bearing of a bird on a tree from a hunter is not 72 degrees east. That is 72 degrees east of north. What is the bearing of the hunter from the bird? We have been provided with the bearing of the bird from the hunter. The bearing of the bird from a hunter is 72. So we are going to use H to represent our hunter, and we'll use B to represent our bird. So we have there 72 degrees, as you can see the bearing there. That's the north, this is our east. So we have 72 degrees east of north. 72 degrees east of north. So from the hunter to the bird, that's the bearing. Now the question now is asking, what is the bearing of the hunter from the bird? That is, if you were to go to the hunter coming from the bird, what direction will you take? Of course, if you're using the compass bearing, then we'll be looking at this angle. And that will be south, and this will be west. It's a very straightforward one. Whatever this angle is the bearing we need. And then we have south, west. So the bearing will be south, theta degrees, west. So what is theta? Now we can say that alternate angles are equal. So 72 here, 72 there. So our theta is what? Our theta is 72 degrees. Therefore, the bearing is simply S 72 degrees west. That's it. You can see there that the bearing will be southwest and theta. So and theta is what? 72 degrees, because alternate angles are equal. So bearing of bird B from hunter H is S 72 degrees west. Lastly, we take question number 3. A girl walks 45 meters in the direction 05 degrees from a point Q to a point X. From a point Q to a point X. Take note again where the bearing is taken from. It's taken from Q. So we're going to first of all locate our Q and then fix the bearing there. So that's it, Q, and the bearing is saying 05 degrees. So we are using the convention of measuring clockwise from the north direction. So this is 50 degrees. And that's the bearing. And it's 45 degrees, 45 meters to the point X. She then walks 24 meters in the direction 140 degrees from X. Now getting to X, the girl decided to do what? Change direction, applying the bearing 140 degrees from X. 140 means we will go first 90 plus a further 50, which means girl is now walking in that direction. So that's 140. Sorry. 140 degrees. Let's draw this out neatly, please. So that's the bearing. She goes 140 degrees from X, and the 140 includes this 90 and a further 50. Of course, that means this will be 40. Yes, you will agree. Because if this is 50, then this will be 40 to make up 90. Also, sorry about that. This angle here is alternate to the 50 we had down here earlier. So that's going to be 50. This is 40, so as you've seen already. So that will give us a total of what here? A total of 90 degrees. Of course, you can see we are already on the way to having a right angle triangle. Let's draw it out neatly. That's it. That's it, 40 and 50. I'll explain again. From here down there is 140. So this other part is 50 since 90 is out. So we have 40 left here. And then this 50 is alternate to this other 50. And that sum up to give us 90 degrees. The question is asking how far is she then from Q? From a new position, which she traveled 24 meters down here. From this new position, what's the distance from Q? If you look at this, 90 degrees, so we have a right angle triangle. And this side will be our hypotenuse. So I can just call this lowercase x. Sorry, I'm already running too fast. There. I can call this Q. And I can call this small letter y. So since I'm looking for the distance QY, we're looking for the distance QY, which is the same thing as x. I can apply Pythagoras there and say, okay, x squared is equal to y squared plus q squared. Why am I applying Pythagoras? Because I can see that I have these two sides already known, so why bother myself? And that just takes me to 45 squared plus 24 squared. That's it, and with that we'll be able to get the distance we are looking for. Let's see how this is done. So since triangle QXY is a right angle triangle, we apply Pythagoras Theorem. We have QY, which we are looking for, is the hypotenuse, so we have applied QY squared is equal to QX squared plus XY squared. Substituting the values of the two given sides, 45 squared plus 25 squared. And that gives us 20, 25, and then 576. Adding that two up, we have 2061. So our QY, taking the square root, gives us 51 meters. So that's it for the second video clip on bearings. We have seen how we can get right angle triangles using bearings. And then next video clip, we're going to look at problems that will lead to general triangles, that is, triangles that are not necessarily right angle triangle. There we again will display our skill on how to do what? Use sine rule and cosine rule. See you.